In this video, we're going to look at the question of finding the tens digit of 7 to the 435th power. This might remind you of the previous question we had a long time ago, which was about, well, several videos back, of finding the ones digit. And what we did for the ones digit, we started hunting for a pattern. 7 squared is 49, which ends in a 9, so, and then 9 times 7 ends in a 3, so we basically got 7, 9, 3, then we got 1, so 7, 9, 3, 1 cycled, and so forth. This is a more advanced problem. I'm bringing this up for two reasons. So first of all, to show you a harder question, and second of all, to tie in some of the concepts we've been discussing. So to do this, we're going to be looking for patterns, but we're also going to look at that simultaneous equation concept in one of the previous videos, or the Chinese remainder theorem, as you may know it by. Okay, so let's see what we would do for this. As you start multiplying the sevens, they're going to start spilling over into the tens digit, so it gets kind of tricky. Like, how do we even approach this? So if we want to know the tens digit, let's say our answer is 5,430, whatever, there's some digits and it goes like this. We just want this digit right here. So we can basically chop off the rest of this and just look over here. Now if you think about this, how do we do this with mods? Well, we're interested in this number, mod 100, because what mod 100 does, it chops off anything that's several hundreds or more and just gives you this remainder. Now if we know these two digits, then of course we can just pick off that 3. All right, now how do we find this mod 100? Well, we can start looking for a pattern. So 7 squared is 49 until we get something that's either like 99 or 101, which will be 1 or -1, and then hopefully raise that to a power. But that might be messy. So what we're going to do is split this into two parts, which is 4 and 25, so related to the prime factorization. Now it's very important that you split it into two parts that are relatively prime. If you pick numbers such as 2 and 50, 2 and 50 have a factor in common, so you'd have an issue there. So these have nothing in common in terms of the prime factorization. So let's consider this number just like we had one of the previous videos where we had x is congruent to something mod something, x is congruent to another something mod another something. So in this case we want mod 4 and mod 25, and we're, instead of x, we know we're trying to simplify this. All right, so what is 7 mod 4? It's actually -1 because it's 8 minus 1. So this is the same as -1 to this power, and -1 to an odd power is just -1. So this simplifies to just -1. Now 7 mod 25 is a little trickier, but if we square 7 we get 49, and 49 is congruent to -1 mod 25. So that means that every 2 sevens get us a -1. Now since, let's see what happens, we have -1 to some power, and what's that power? It's going to be 200. We're dividing this by 2 to get 217 with the remainder of 1, so we're going to have a leftover 7. So since each of these two give us a -1, -1 to an odd power is -1, and -1 times 7 is -7. Now we want to bring it into our 0 through 24 range for our normal range, so we're going to add a 25, which gets us a positive 18. All right, so and it's at this point that we're going to use a similar technique to that previous video, finding simultaneous constraints. Okay, so we're looking for a number, and also let's, -1 is no good, let's bring this into your 0 through 3 range, so add a 4, that's going to be a 3. All right, so we were looking for a number that's 3 mod 4, but that's 18 mod 25. So let's start with the larger constraint. So let's just guess 18. So is 18 mod 4 equal to congruent to 3? No, it's congruent to 2, the remainder is 2. So this doesn't work. So let's try adding a 25. So that's 43. Is 43 mod 4 3? Yes, it is. So this tells us that our gigantic number will be something, 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 and 43 at the end. So the tens digit will be a 4. So notice we've tied in several concepts in this video, which is looking for patterns but simultaneous equations as well related to the Chinese remainder theorem, or simultaneous congruences. And I'll leave you guys with that. Now you could have asked, find the hundreds digit or thousands digit. So let's say we had 1,000 for find the hundreds digit. We would split this into 8 and 125 and run the same sort of program, same sort of idea. All right, I'll see you guys in the next video.